I think we're going to get started now. Hello, welcome to the Bay Area Kubernetes Meetup, and thank you all for coming out here. And thank you so much to NetApp for hosting and for the delicious food. I'm Solly Ross. I'm a software engineer on GKE and one of the organizers of the Bay Area Meetup.
Hey everybody, my name is Duffy Cooley. I'm a staff cloud native architect at VMware, and I'm also one of the organizers of the Bay Area Meetup. We're starting to kind of expand the organizers of the group. And so I look forward to seeing more of you as time goes by.
All right. As usual, check the Meetup page for more information on what we're going to be doing next month. And with that, I will hand the microphone over to our speaker.
Sweet. Hello, everyone. I'm Paul Bird. Nice to meet you. I have two more announcements because we love announcements. So these are fun announcements. The little cards you see on the sidearms of your seats, that's a chance to enter a raffle to win a drone. So that'll be announced at the end of the event here. And I believe when Scott gets up, there's another raffle for Istio and Action Book. So you're getting all sorts of raffles tonight. That'll be excellent. And I've also been told that the Kubernetes 1.17 release team are looking for shadows. So those are people interested in participating in the Kubernetes release process. No experience is necessary. So head to the Kubernetes website and check that out, or ask around on the Kubernetes Slack if you're interested in joining that. It's usually just a commitment of like 8 to 12 hours a week, potentially. So that's a good one if you're interested in getting some Kubernetes on your resume. Sweet. All right, we're done announcements. Now we can talk. I apologize. These slides are actually from a presentation I gave 2 days ago at GitLab Commit in Brooklyn. So these are somewhat GitLab themed, but I promise you we will be discussing Kubernetes tonight. My discussion is around Kubernetes platforms. I work on a Kubernetes platform at NetApp. It's NKS. And something has sort of struck me in that everybody seems to be announcing their Kubernetes platform. We have VMware has a number of them. I talked to someone from Ludsi earlier. NetApp has one. Everyone and their grandmother has one. It's like, look, Martha, this is not a cookie distribution platform. This is a bake sale. You don't need to call everything a platform. I want to dial into why everybody seems to be so platform obsessed these days and what the real value is, why we end up wanting to spend money on that, because I think it's somewhat fuzzy. So in order to get into that, we're going to do the clunky thing of defining things that are usually pretty fuzzy. I'm going to try and keep it light though. So I will simplify this as much as possible. In the process of simplifying, I will probably miss important notes that you think are essential to what this thing is. So to that end, if you think about DevOps, cloud native, platforms in general, we'll touch on those three terms, and then we'll dive into sort of some lessons that I've picked up working on a number of platforms from CoreOS days to Red Hat to my current home at NetApp. So DevOps is a combination of cultural philosophies. I'm not going to read the rest of this definition. I don't think anyone defines DevOps this way when they're talking in like plain English. It's someone asks you what is DevOps, you usually are going to give them an answer that's much more akin to, look, it's a culture where regardless of your title, you share work, you share responsibilities. So if someone works in security and someone's a developer and someone's an infrastructure person, you don't just get to say, okay, you own infrastructure, you own security, I own development. It's we all own everything together. And this is from Ken Mugrage. He is a DevRel person at ThoughtWorks. So if you enjoy this sort of plain English description, I highly encourage checking out his blog post on this, and he has some talks as well. So to me, this is the simple way people describe DevOps to each other. Similarly, cloud native technologies empower organizations. Again, I don't think anyone actually talks about cloud native technologies this way. To further complicate things, the stuff that this contains is pretty wide. It's anything from containers to service meshes to microservices, immutable infrastructure, alligators, crocodiles. I don't know. It's everything under the sun. So making sense of this is relatively complicated. It's even more complicated when you go back to 2017 and look at the definition on the CNCF website. Point number 2 here is really important, which is it's containers that are scheduled and managed. And it has since grown from that into this much broader thing. That said, there is a thread that runs through all of these things. And that thread, I think, is illustrated by JBD here. She is a Go author and DevRel at Google Cloud. If you work in the Go ecosystem, you've almost certainly used some of the packages that she's written. And her definition is great. It's just that cloud native is where failure is the default state of your system. You're assuming that everything's going to fail. What's the behavior in that case? So we're going to talk about cloud native in that context. I think it's also useful to use cloud native in sort of a, if you ever took like an archaeology or anthropology class in college, they talk about BCE, before Common Era, or CE, Common Era. To me, cloud native sort of signifies that. It's like, oh yeah, the cloud native era. Cool, it's something that's been written in modern times. And our final definition is, what is a platform? I've struck out as a service because who buys business software that's not as a service these days? Has anyone made a purchase like that recently? No Sublime users? Oh, one Sublime user maybe? So it's a rare thing. Out of the room, we got one hand, and I think it's about time we just strike the as a service piece and just say it's a platform or it's a service, that sort of thing. Similarly, this definition works very well for academics, potentially, from Martin Fowler, for what a platform is, but I don't find it particularly useful in describing it to someone who is unfamiliar with a platform or coming to a shared understanding where I'm in a conversation with someone and we have different ideas of what a platform is. You know, we talk about the web platform a lot. That's HTML, CSS, JavaScript. So using that to build application of sorts. There's the LAMP stack, which is a platform. It's the Linux platform, potentially. Linux, Apache, MySQL, PHP, that's popular, was popular, it's still popular. And then there's stuff like Heroku, which to me is really synonymous with platforms. And Heroku sort of rose on the back of Rails. And what was really unique about it is, as a developer, you mostly just develop your application, and Heroku kind of magically mostly takes care of scaling and all the other hard stuff, administering your database. All those things just sort of, they seem like they work. It's like everything fits together really nicely, like a puzzle where someone's taken the time to fit the pieces together instead of taking a hammer and just kind of smashing them together, hoping you eventually wind up with something that looks all right. And to that end, I think the Rails doctrine is very useful for talking about what a platform is. They have a lot of values on there. These are 3 that I've handpicked. Convention over configuration. You value integration in your system. And the menu is omakase. And that last one, I assume there aren't any Japanese speakers in the room? No? Yeah, I don't speak either. But the way they define that is the menu is sort of preset. The chef looks at the ingredients, they combine the ingredients for you, and then you order on the menu. If you need to tweak a recipe, say you're allergic to shellfish or you don't eat meat, something along those lines, you can always request that, but you're gonna get a meal out of the box. You're not gonna get a collection of ingredients. Huh? Oh, yeah. Thank you. Your platform should be something that works out of the box, and it should be easy to customize if it doesn't fit what you need immediately. So a cloud native platform, everybody seems to have one of these days, including NetApp. It's a platform where you've built it where failure is the default state, and you want all of the components that you've built together to nicely integrate. And that sounds simple and basic and straightforward until you know, you start thinking about what the cloud native era is. When we talk about the web platform, when we talk about the LAMP stack back in the good old days, most of that work was, you know, you could upload a file to an FTP server and just have it work. it was relatively straightforward for how you developed and committed things. These days, we're looking at something like this, which is either the most brutal vision test you've ever taken or the CNCF landscape. So there's, I think, it's approaching 500 plus projects. All of them aren't even displayed on the screen. There's a whole other serverless landscape that is in addition to this. And if you're developing your own Kubernetes play, you're looking at assembling pieces from all of these categories together yourself and creating a functional system out of that. So it's not just daunting in terms of how do I build it, what do I do? It's which pieces of these technologies fit together the best and are going to provide the best value for my business. And that's pretty tough when you're looking at 500 plus different parts. So cloud native, the era that we're in, it's a Cambrian explosion of complexity. We're not just dealing with 3 components, HTML, CSS, and JavaScript. We're dealing with at least 20 or more components that you have to assemble together and build into that silky platform experience, that Heroku experience where you can order off the menu and it comes out as a complete meal. It's something that just works. So at a minimum, I think these are all the components that you would need, about a dozen or so, to have a functioning Kubernetes service or a functioning Kubernetes platform. I think service mesh and a custom catalog are probably optional, but at the base, you're looking at filling each of these categories. And I've done a one-to-one matching here, sort of selecting components that might fit, but not all of these fully satisfy each of the categories that they belong to. Dex basically just handles OIDC. You still need to build a nice web UI for that and integrate that. Kiali actually happens to be like a number of components. It's like 6 or 7 different things that represent a tracing model and a service mesh. So this is very, very complex. And similarly, in the DevOps space, if you're buying a DevOps cloud native platform, it gets even trickier. So when we stray away from just what Kubernetes is and what Kubernetes does, we're looking at the modern software development lifecycle. When you get to shared responsibilities, we're looking at that CNCF landscape, but a lot of the tools need to span multiple categories. So we're not just integrating, point A to point B and doing a nice handoff, tossing it over the wall is what we used to call it. A lot of these tools need to overlap and do so in a very large, big way. That said, when you consume a platform, when you're buying something that you want to use, you don't want to see that. You don't want to see those overlapping layers. You don't want that complexity. You want a straightforward point A to point B. This is what my developers get. This is what my infrastructure people get. You want a clean workflow. And ideally, when you're purchasing something, this is what you should see. You should see a simplified sort of view when you're working on a platform. And that simplified view is what we message when we're selling a platform, and it's what VMware messages and what LUDC messages. And when you are evaluating a platform for your business to use, you should see messaging like this, but you should also experience this when you use the platform. The pieces should fit together really nice. You shouldn't really notice exactly what the ingredients are necessarily, but the same way when you're eating a dish that's omakase, if you get a hint of garlic or there's an orangey taste, that's fine. But you shouldn't be overly concerned with what those components are. It should be assembled nicely so that you can use it. Cool. Any questions so far? All right, we're gonna jump into some quick things, just some suggestions for what I've learned working on Kubernetes platforms since I was at CoreOS a couple of years ago and now at NetApp. So the first note is, on that list of the 12 essential components that you need for your platform, I'd say half of them were probably security related, and you really do need to invest in security from the outset. It's kind of non-negotiable these days, and We see this with terms like DevSecOps and the shift left philosophy, all those things. That said, security is not a solvable problem. If you believe security is a solvable problem, I'd like to invest in your startup. But the reality is that there's always new exploits, always new bugs, new techniques being released, and you're not going to be able to get everything into your platform from the start. So when you run into security enhancements that you can make, mirroring or shadowing traffic, which actually Scott Cranton is going to talk about tools that can help you do that after this, is a really great way to implement security policies and test what they will break before you actually flip the switch and cause production to go down potentially. So definitely look into mirroring and shadowing traffic after you make a policy change or you're planning on making a policy change. If you're not familiar with this concept, the 0, 1, or many concept, this is the idea that you should design your software so that it can accept 0, 1, or many of something when you're doing CRUD tasks. I think this is sort of a lie. And this is a lie in that if someone doesn't tell you like, oh, this can only handle up to 100 requests at a time, then what they're really saying is there are no safety rails on the software. We don't know what happens when this breaks. You get to figure it out yourself. So in the case of Kubernetes, some of Duffy's colleagues, Josh Rosso and Craig Tracy, gave a great talk at KubeCon Barcelona. And in their talk, they basically suggested in their experience implementing a lot of Kubernetes platforms for people, about 500 nodes in a cluster is a sensible limit. Once you get to 500 nodes or beyond, what you're gonna find is you have to do a lot of cluster tuning to really keep things healthy. Things sort of get bogged down. So at that point, you wanna start thinking about managing multiple clusters. Which brings us to multi-tenancy and blast radius. So Jess Frizzell has done a lot of great work on multi-tenancy. She has an excellent blog post on that. You can just search for Jessie Frizzell, multi-tenancy, and it's specifically targeted to Kubernetes. Essentially, she suggests that Kubernetes doesn't do a great job of handling multi-tenancy in that if you had multiple teams or multiple customers on the same cluster, and you needed a hard separation between them, that's relatively difficult to achieve. And that can lead to a lot of noisy neighbor problems, which is the blast radius. What happens when someone messes things up for everyone else? So what's really essential to me then is that means you need an easy way to create multiple platforms. You need a push button or an automated system to spin up multiple clusters. You need to be able to manage multiple clusters when you're looking at a Kubernetes platform. So if you are buying a Kubernetes solution and you don't see that in there, you're missing a very critical piece of the puzzle because you will run into multi-tenant issues or blast radius issues down the line. Oh, that's Jessie Frizzell. Yeah. And I believe her work is actually in the official Kubernetes repo. It's a design document that she created a year or two ago, basically exploring multi-tenancy for Kubernetes. So by the undifferentiated parts, this is a classic Netflix saying. This is part of why they moved to AWS. Their value at Netflix isn't in delivering the best software in the world. Their value is in delivering the best video experience in the world. And this is true for most of us as well. At NetApp and NKS, we believe very strongly in open source components, and we try and assemble our platform from them. But not everything has to be open source. I do think it's relatively important that the platform is open source. So Linux should be open source. Kubernetes needs to be open source. I would not dream about building on top of another solution that was closed. And the reason for that is just closed platforms often fail to deliver on that menu as omakase promise. That really means that if you need to modify the menu or tweak it, it's just not possible when things are closed, or they essentially will force you to choose the options that benefit them the most, not necessarily the options that benefit you and your business the most. So you always want that option to be able to customize things just a little bit, even if you want it integrated well out of the box. And this is what people call a walled garden. The walled garden is you basically get to choose from 8 or so projects that have been accepted and branded as good for that business, and everything else is sort of off the menu. And that doesn't really cut it in this day and age, especially in the cloud native age when there's 500 plus good solutions that could work better for you and your business. You really need to be able to swap out and modify things if you find they're important for your business. I'll close this section by just saying that most platforms are some combination of open and closed. So simply saying, oh, that's a closed platform, kill it, it's terrible, really isn't a great argument to get into because everybody, unless you're a real open source zealot, tends to use something that's some mix. So you got to get pretty refined in how you discuss these things. I'll also say that serverless to me is just another name for a platform. It's a platform that gives you better configuration defaults, and it automatically scales your workloads for you, and it does all these things that we are used to doing with other old platforms. If you remember Heroku, that was their promise as a platform. To me, I don't see a lot of difference between the serverless technology that's on the market and kind of the promise of these old school tools. And I get frustrated when I see people who are really invested in serverless technologies talking shit about containers, and vice versa. If container people are really bad, like banging on serverless, like, oh, they're so stupid, why are they doing things that way? No one will do it. Like, it seems silly to me. All of this is kind of converging to the same space. Serverless is just a really nice name for a workflow that is nicer to your developers. And that's something that Kubernetes misses right now. Kubernetes is much nicer to your operators, the people running the infrastructure, but we're still figuring out how to make it approachable to your application developers. And serverless is one way to do that. Closing, I'll say that even though what we're searching for in a platform is something that's nicely integrated, we're looking for that omakase meal, the meal that the chef has prepared for us that is delicious and all the ingredients fit together, taste great. You similarly want a seamless software experience. You download a platform, you install it, you can sit down, get going, looks beautiful like this as soon as you get going. Eventually, you're gonna look around and say like, wait a minute, that side table looks kind of ugly. I think I want a different coffee table too. And that leads you here. So you always wind up in the warehouse buying flat packs, bringing them back home and cracking open the screwdriver and hammer, and you always wind up needing to customize it to some degree. So even though the ideal is something that's integrated, that you can push a button and have it just work, we will never actually meet that ideal because every business is different. Every software team is different. Everybody is going to have different needs just a little bit. And that means you're always going to need to customize. So wrapping things up, can say platforms strive for these push button experiences, these pleasant experiences where everything's integrated. To me, that is the simplest way to define a platform. You're getting something that just works. In a lot of ways, that's what we get with Apple products. You tend to buy a piece of technology, you use it, it just works. And there's lots of options for things you can plug in and install and do all that stuff with. And this is how it's messaged as well. So, my company is no exception. If you're interested in checking out the platform that I work on, it's this URL. And that's the talk. Any questions? I'm seeing golf claps, so I'm gonna assume no. One question here. Yeah, I mean, the trend is what I've seen is if you really have an issue with needing to separate workloads, what Jesse Frizzell calls it is there's hard multi-tenancy and soft multi-tenancy. So the question was, describe the multi-tenancy issue that was brought up earlier. The hard multi-tenancy is essentially having any random person from the internet be able to deploy something to your cluster and have it run. And Kubernetes does have a lot of tools for tweaking and configuring that stuff, but it's really not good enough for taking untrusted code and executing it on your server. That's the big conclusion of the report that Jesse puts out. She does say that if you have a lot of developers who are working together and they're on a team and they're semi-trusted, and you can believe that they won't necessarily be noisy neighbors, there are some tools like Limit Ranger, which is an admission controller on Kubernetes that can apply kind of defaults for how much of a resource any one pod can consume. Those are good ways to enforce soft multi-tenancy where there's some trust in the system. But you're still relying on some trusted relationship, and there's always bad actors. So to some degree, there's a really good argument for having one cluster per sort of logical unit. So if a team doesn't necessarily need to communicate with another team across the way, their projects are somewhat separate from each other, it may make sense for each of those teams to have their own Kubernetes cluster that they deploy to. And it's relatively easy actually to expose traffic from one cluster to another. Services have a nice mechanism for grabbing traffic and pulling it inside. So that's not too hard to sort of figure out. But the big piece is just that from a security standpoint, running untrusted code and doing hard multi-tenancy is really, really difficult. And protecting yourself from blast radius from a bad actor doing something really catastrophic to your cluster tends to be relatively hard to do with current Kubernetes settings. So by having multiple clusters and administering them, you're lowering the damage that can be done with any one destructive action. There's a great Kent Beck quote. The answer to any complex question is it depends. So I think that's what I'm unfortunately going to tell you right now. I think it's very common to have just virtual machines as a separation. That's the most common that I hear people talking about, but you'll find situations where people absolutely do need different nodes separating the workload. So it probably depends on like if you're working in finance and other like highly sensitive sort of data sets and regulations and all that stuff kind of comes into play. But Duffy, actually, one of our hosts here, talks to a lot of different companies and a lot of different verticals. So he probably has a great perspective. I would grab him after the talk. I'm volunteering you for work, Duffy. He's a good guy to talk to about this sort of stuff. Cool. All right. Thanks, everyone. Our next speaker, Scott's coming up. Oh, oh, I do. Okay. Either one of us? Yeah, they did. Want to give people a minute? Dive right in.
Okay, we'll dive in. Hi, Hi, so I'm Scott Granton. You all hear me? I think this mic's working. Okay. So I'm from Solo, here to talk to you about, Solo does not do a Kubernetes platform. So we are not one of those. We do not provide a platform, but we're going to talk about ingresses, API gateways, and some of the technologies around service mesh that we've been working with. Now there is a raffle. So Christian Posta works for us. He's been in the process of creating the Istio in Action book. He originally said he was going to do it for when 1.0 launched, which he missed. So now I'm joking with him that by the time 2.0 comes out, the book should be finished. But so, you know, we're giving away about 5 of these books. I think that this link went out on the meetup. If not, we'll send it. But I think I think the intent is to give away 4 or 5 of these copies. So if you fill out, I think this little survey or whatever, then you can get one of these books and we'll update. You'll actually get the real book when Christian actually finishes it. So, Solo, I'm going to talk a little bit about what we usually talk about as a journey to cloud native. Now that Paul's going to define what cloud native is, thank you. I don't have to do that. But we talk about most companies or most teams within a company kind of fall into one of these stages and are kind of again on this progression. So we see a lot of companies and teams that are dealing with sort of modernizing. Generally that means going to microservices on Kubernetes, you know, a given audience here at Kubernetes Meetup. But a lot of it is that kind of environment. So they've got existing applications. They're thinking about how do we modernize it? Do we go to microservices? Do we go to serverless? Do we do something else? How do we do that? How do we keep the lights running on the applications that we have? So it's I don't know if this mic's working or, oh, there it is. I hold it closer. So they're trying to figure that out. And so they're trying to figure out how to make that move and do it safely. You know, the idea of like re-platforming, changing code it can be difficult because if it doesn't work, you got to cut back. So how do you kind of do that in a way that allows you to experiment and find something that works and then move with the things that work and throw away the things that don't work. And my intent is, I should back up a second. My intent is I'm going to talk through some of these things and I'm actually going to try and do 2 live demos. So I'll try and make some of these concepts real at the end, and you can always laugh at me if the demos don't work. That's always the fun part of live demos. So generally, if people survive the microservices kind of journey, they start getting into it. Hey, I got 5 microservices. I'm pretty happy. Then I got 10. Then I got 50. Then I got 100. Then I got a couple hundred. Whoa, like this is hard. Like lots and lots of microservices. I built like this thing that feels like a highly distributed application. Hey, and failure is the default mode. Like, so things are going to break. So what do we do then? So that's when people kind of get to the next leg of our journey, where people start looking at things like service mesh, but how do I scale this out? Becomes the bigger concern. So service mesh is certainly a key technology that a lot of people use in that front, but they're trying to figure out, you know, how do I ensure that there's secure connections between all of my microservices? How do I actually have visibility? If I've actually done my DevOps thing the right way, if I've actually got multiple teams deploying in production in parallel, that's really cool, but I probably have absolutely no idea what the call graph is through any of my applications. And in fact, it's going to change on a regular basis, and it's probably going to be almost impossible for me to reproduce that outside of production to actually simulate the same production call graph. So again, how do I get observability? How do I get security? You know, how do I get sort of traffic management patterns around that? This is, again, so the classic area that service meshes kind of look at. And we've been helping on that front. And then, you know, even in that space, that's all cool. But what if I've got multiple clusters? You know, again, Paul sent me out, we actually talked at the New York one, but you know, the idea of multi-clusters, and maybe I want smaller clusters, maybe I want to do multi-region. Well, now I've got multiple service meshes. So wait, I've traded off, I've now got my microservices under control, but now I've got multiple meshes. Whoa, okay, this doesn't, so how do we kind of manage that problem? And then so we've done a lot of work on this front. And then we're starting to do some experimentation. I've done it at the New York Kubernetes Meetup. I did a talk on chaos engineering. We think that once you've got a service mesh in place and some of the network capabilities, you know, you basically have proxies everywhere. You can do some very interesting things there. You can do interesting tests around chaos engineering. So you can actually come in, because you've got proxies, you can actually simulate failures in production, so I can say, hey, on this link, I want 20% of the calls to result in a 500. The upstream service is not actually failing. I'm just catching the network message and I'm saying, okay, make it fail. Or I'm going to introduce delays. Now, why would you do that? You're going to actually see how your system would handle failure scenarios. During the business hours, when you're there, when the team's actually paying attention and knows that there's a test in place, then and only then are you going to actually say, hey, let's go, put some really nasty scenarios in front of our application and see what happens and see if anything breaks. And if it starts to break too much, then you want a way to say, okay, stop the experiment, let's go and fix it. Now that's way more desirable than at 2 a.m. on Saturday having that failure happen. That sucks. Because that's when you get paged, that's when somebody's yelling at you on your phone, you're like, what? That's when you gotta get up. Nobody wants that. So the more you can do on that front, really, really good. So that's some areas that we're doing some initial experimentation around. But for this talk, I'm gonna kind of focus more on the first two. And this is also what I'm gonna demo. So Glue is our API gateway. We've done a lot with that. And then Service Mesh Hub is dealing with multi-mesh deployments and kind of an abstraction layer on top of mesh. We are not another service mesh provider. The world has too many of them. When we started doing a lot of this, there were 4. I think there's probably 8 that have been announced out there now, probably more. So we don't think the world needs another service mesh, but we do realize that there are multiple meshes. How do you manage these different technologies? And how do you deal with the fact that maybe they're deployed in multiple clusters? So what does this all mean? Like, what the heck am I talking about with all these things? Who's played with like Istio or one of the service meshes? Okay, a few people. Yeah. So, okay, let me explain what the heck I'm talking about. So most people, when we're talking about a typical microservices architecture, and this is really kind of where Solo is focusing on, is how do we provide a clean abstraction layer to build applications on top of this? And that's where a lot of our open source projects are. I should qualify that we do a lot of this in open source, so you can always go and play with it yourselves. So generally, people think about this in sort of 2 dimensions. The first dimension is what people call like sort of north-south traffic. The idea that I've got traffic coming into my cluster and out of my cluster. And how do I manage that? And that sort of has a set of concerns. Security tends to be a big concern for a lot of people. How do I authenticate it, authorize it? How do I do web, like application firewalls, rate limiting, all these kinds of access logs, like big area of concern, like who's coming in. But also people want to think a lot about, how do I now route, classic Kubernetes ingress style? How do I take this traffic and route it to one of the microservices inside of my cluster? Because there's kind of a disconnect in the world. So how do I get to the right cluster? Or how do I even do more sophisticated like canary or blue-green or A/B load testing? So if I want to send fractions of traffic to certain microservices, I've rolled out version 2, I only want to roll 10% of my traffic from internal users to my new version until I feel good that it's working, and then I'm going to give it more traffic and then more and more, and then I'll actually give it production load, or traffic shadowing is another one. So how do all of these I kind of put into this bucket of north-south. And then the other dimension people think about is the idea of east-west. Now I've got service-to-service interactions. And there's similar concerns there, but people tend to think about it differently. Occasionally I've seen people put security domains across this, but they're generally less concerned about that. Certainly not to the same level they are about thinking about external traffic coming in. But they want some level of security, the potential for a bad actor, putting a service in, how do I kind of safeguard, contain the blast radius a little bit? How do I deal with that? And all these little boxes, these little hexagon boxes are a proxy approach that come in. So as you go from, if I back up, in a gateway scenario or an ingress, people talk, and Nginx tends to be the classic one. Paul was talking about earlier. In the sense, Glue is sort of like a Nginx, but better. And I'm going to talk about why. But so we got proxies there, but you might only have a few of them, and then once you get to this kind of east-west, you basically have a proxy for every single service that's deployed. So this is talked about as a sidecar pattern, which is very classic classically associated with service meshes. Istio in particular put this out, but all of the, Istio, AppMesh, all of them kind of do this approach. And this all kind of comes out of the genesis. I don't have a slide on this, but basically this is the genesis or sort of an evolution from what a lot of people did with like Netflix OSS. So they took a lot of sort of this classic operations code, service discovery, retry, circuit breaking, all those sorts of concerns, even to a degree, authentication, authorization, and said, hey, that got built into a framework. So Netflix built this into a framework that was deployed with your business code as people rolled out more and more versions of it. That's cool if you're doing Java. Now I want to do something in Node.js. Oh, well, now I got to use a different library. Oh, I want to use Go. Oh, okay, now I've got to write yet another library. And all of those libraries kind of do circuit breaking a little bit differently, and they all do it, and now you've compounded your problem. So the folks at Lyft, and a couple other companies did it, but we think Lyft and Envoy did a really nice job. So Lyft as a company said, hey, they had that concern, and they said, well, instead of, since they had a lot of smart networking people, they said, let's put this in as an external component and use the network as the API. Every programming language can talk to the network, and we'll move all of this code into a separate component, which was those little boxes that are the proxy. So we're going to put that into a proxy and say that these concerns are going to be external. So I can version them independently. I can associate them with any business logic out there without the people writing the business logic actually caring about it. And then I can externally control that. So now that gives me a lot of power and flexibility. We think that, it seems like a small change, but it enabled a whole interesting set of capabilities. And so when the Lyft folk did this, they kind of thought of a few areas of concern on this. So one, if you're writing a proxy and you're saying, hey, this thing is going to go, proxy, capture all of the traffic on every single service, the thousands of services I have deployed, it better be pretty darn fast. So they wrote all of this in C++, and the overall head's about a millisecond, a little less, for this architecture. Now, in comparison, most like API management strategies or traditional kind of gateways like Nginx and others, probably on the order of like 20 to 30 milliseconds around this. Again, doesn't seem like a big deal until you're starting to think about, if I've got 1,000 services and every one of them is now dealing with a 20 millisecond hit versus one, okay, it adds up. It impacts customer performance. It impacts the amount of hardware you've got to deploy. So it has a lot of concerns. It kind of adds up. So that was sort of one big concern they looked at. The other one they looked at was extensibility. So Envoy itself is a filter chain architecture. So it's the idea that I can have a series of filters, components that can look at the traffic. I can dynamically load them at runtime. And they built a very, very flexible configuration management. So external parties can manage the configuration, the security, what plugins are actually loaded, what the traffic patterns are at runtime. So this has really turned out to be a very powerful capability because like in our north, south, east, west traffic, I can take the same proxy, the same basic code, the same way I operate it, the same way I deploy it, and tailor it based on my usage. If I'm putting it on the edge of my environment, I can put a lot of the security filters in place and say, okay, hey, we're going to do security, we're going to do this, we're going to do that. If I'm using it for east-west traffic, well, maybe I don't need a web application firewall there, so I'll turn that off, but I'll want things like open telemetry. I want to start doing tracing within my service to server. So I can turn on and off these capabilities as I need, which is very, very powerful. And people talk about this as a control plane. Is the idea that you have something outside that's managing Envoy acting as the data plane. And this is a very classic, again, we love Envoy. We were the, I think, number 2 contributor for a while as solo. I think now I don't think we are anymore, but a lot of people have joined the party. We've done pretty well for a small company, so we were pretty happy about that. But this technology got picked up by Istio, by Amazon AppMesh, by a lot of others. So a lot of people decide this is really, really cool. And which kind of goes to my point in the community. So Matt Klein at Lyft, when they created this, Matt made an active decision to not create a commercial company around this. He felt like he didn't want to do that. He wanted to get it out there because he wanted it to it's not that Envoy's a platform, but he felt like it was close. And so he wanted it out there so that there was no single kind of controlling entity around it. And that was a really awesome decision because a lot of other companies jumped on and started using it and contributing it to it. You know, even Amazon's donated a lot of their code dealing with like EC2 and some of the security plugins that they've got. They've just recently added them as Envoy filters. So like EC2 has a concept that it's kind of like a service account, but they can associate security credentials with an EC2 instance, and Envoy can actually pick that up and carry that credential, and so you can use it for authentication and authorization purposes. You know, so if you get your identity access management in Amazon, you can kind of carry all that through, and all your rules just automatically flow into the system. That's really, really cool. So even like, you know, Amazon and others, my point is people are contributing to it from a community perspective. And we think that's huge. And the expectation is like Envoy Con is happening the day before KubeCon. And I think there's an expectation of well over 1,000 people have signed up for the Envoy Con part of that. So the community itself, just over a few years, has grown pretty large. So Glue is we have an open source API gateway. So it's acting as that control plane. So it's setting up, so Envoy itself, you know, can take those configurations. That's what Glue is, setting up the configurations and actually monitoring it to make sure, did those configurations get into place, and what are the metrics coming out of it, and how do we kind of deal with that? And so it's kind of controlling a lot of that. And it can control multiple proxies that are out there. So it's not a mesh in the sense that a mesh typically is dealing with sidecars, every single service. So Glue as a technology is more focused on a few proxies out there and dealing with more of that's kind of the edge security constraints. Tends to be where its design center is. You could have a lot of, I mean, there's nothing stopping it from running one proxy per service. It's just not necessarily set up to do that because, again, we didn't want to be yet another service mesh. So the architecture itself, you know, core of it's all open source, very flexible plugin system, a lot of it courtesy of Envoy. We've added a bunch of filters in there as well, some of which we've contributed to the upstream community. It makes it very easy for it to kind of build out a tailor-made solution for kind of what you need, and it's quite extensible. It uses a controller-based architecture that you know, Red Hat, the CoreOS folk talk about as the operator SDK. We did not use the operator SDK, but we started building it before that really became the thing. So we use the Kubernetes controller architecture around this, so it's all CRD based. So it's very cool. I think it's very cool. So an example of a lot of the plugins that we've got. So we've done a lot of work with mod security we've built into it. So we can do full out web application firewall. So you can do all the message inspection, you know, cross scripting and all that kind of fun stuff. We can do a lot of deep inspection on that front, as well as, you know, the expected sort of authentication, authorization capabilities out there. We're working with, you know, Open Policy Agent. We're working with OpenID Connect, JOT. I mean, there's a lot of cool stuff we're dealing with. And we can do a lot of things around traffic shifting. So the security is pretty cool. A lot of people want that. Also, people want the idea of how do I do, you know, traffic shifting. Canary is a big one. So people talk about blue-green, but how can I send like 10% of the traffic to this, 90% to something else? That's a pretty kind of cool capability. Or traffic shadowing. So I can send 2 streams of traffic out, and so I could put, my new version could be capturing the real traffic, but not actually, the response is not going back to the user. So you can kind of monitor it. Is it going to work? But not do it. So there's a lot of kind of very interesting things you can do there. And I guess, you know, since I'm at the Kubernetes meetup, I'm going to talk about the fact that I mentioned already. So like the idea that it's CRD based. So we actually wrote Glue a couple of years ago and then rewrote it to say, look, we wrote it off Kubernetes and then we rewrote it to be on Kubernetes, which has been kind of a good decision in the sense that, one, we're on Kubernetes and that's really good. And we made sure that it was kind of deeply integrated with that, but it also allows us to work off of Kubernetes, which has turned out to be a very valuable thing for people in that, particularly that modernization thing. The fact that I could run the same proxy technology just on bare metal or VMs is pretty cool. And the fact that, you know, if you are running it on Kubernetes, it'll just work with etcd as a storage mechanism, no database required. It just works. It's just manifest, so you can do GitOps and you can do all that kind of good stuff. All of your, you just kube apply stuff and it just works. It's just kind of cool. But again, we can kind of work with external environments. So if you're running off of Kubernetes, we can work with like Consul. It's kind of like the stand-in for etcd. And we can use it as a service discovery mechanism. A lot of people use Consul to act as a service registry off of Kubernetes, because there isn't normally a classic one. So we can kind of connect to that and use that to come in. And I'll kind of show that a little bit. So if I summarize a little bit, because I want to make sure I get some time for demos, because that's always the fun part. That's like NASCAR. You want to see, is the guy going to go hit the wall? I don't know. So, service mesh is coming. We are very excited about service mesh. We're doing a lot with that. I didn't talk as much about service mesh hub. I should say, like, we did work at Kubernetes Barcelona, or KubeCon Barcelona. Let me back up a second. So we did a project in November of last year called Super Glue. We did a multi-mesh translation engine. So we worked with Istio, AppMesh, Linkerd, and Consul, and we came up with a common service mesh abstraction so that you could apply a policy and it would translate it to the different mesh technologies. So it gave you sort of one API to manage multiple. Microsoft reached out to us and said, hey, that's really cool. We would like to kind of work on a joint spec and get a bunch of other players involved. And that was what was announced at KubeCon Barcelona as the service mesh interface spec. So Microsoft, VMware, Red Hat, Pivotal, Buoyant, HashiCorp, everybody's kind of jumped on to this standard that, thankfully Microsoft is helping us champion. So it's kind of based on the technology that we built out and now is being extended beyond that, but it's a common API for dealing with service meshes, which I think is a really good thing because, kind of like if you harken back when like Kubernetes started, there was a lot of different orchestration technologies out and people kind of, did I pick the right one? What if I picked the wrong one? Now I've got to replatform. So the idea that there's a spec you can start building automation against, it should allow people to experiment. I think it's a good thing in the sense that it allows you to experiment without kind of necessarily committing. Because I think a lot of people are still trying to figure out what value can a mesh do for me. So we think mesh itself, very powerful. We're building a lot of technologies to help increase adoption of mesh and kind of complement it. And kind of get people started with it. Security is definitely a big thing we're working on. I've talked a lot about that. I didn't mention as much on the serverless. So Knative actually adopted Glue within the project. I think it was a .6.7 release because Knative is basically doing traffic shifting. So originally it started with Istio, which was cool. But a lot of the community kind of pushed back and said, hey, Istio is great, but really, really big for just scale to 0 and back. Like, do I really need that? So Google reached out and said, hey, can we use Glue to just do that part? And so we became the first alternative to Istio within the Knative project, which was kind of cool. And now that's opened up a bunch of Scott Weiss, who also works with Solo, did a lot of the work within the Knative community to kind of, I don't want to say de-Istio because it's not a negative connotation, but kind of build that abstraction so that other technologies could come in. And now because of that, the Knative project can support a lot of different traffic shifting kind of capabilities, vendors as well. Of course, Glue is the best one. Don't pick any other one, but there are other options out there now, which choice is a good thing. And then we can also work with things like Lambda and Cloud Functions and stuff like that. And I'll show you that in a second. But the ability to kind of call out, again, that experimentation. Do I want to do microservices? Do I want to do serverless? Do I want to mix and match? I'll show you that in a second. And then we've done a lot of work with the Continuous Delivery Foundation. The Jenkins X folks adopted this technology to kind of help with serverless adoption as well as some of the traffic routing. And Weaveworks has a great technology called Flagger, which kind of automates a lot of the Canary deployment. So good stuff to kind of play with. This is kind of a summary. I think I've touched on most of this. Oh, yeah, and this is the important one. So, so we do have a lot in open source. We do have an enterprise version. I do like to feed my children. So definitely if this is cool technology and some of the other enterprise features are appealing, please, I need to feed my children. So, if we can help you on that front, that would be really cool. But definitely try the open source. I had the pleasure of I spoke at a number of the Canadian Kubernetes meetups up in like Toronto and Montreal and Ottawa. One of our open source partners, a company called DTech, is actually using the open source version of Glue in production as part of their HR application. I had the great pleasure of joint presenting with Felix Roberger on that. So, you know, we actually have, you know, people that are using the open source in production. It does a lot of really cool things. Though Felix is looking at the enterprise one because he liked the console that I was showing off, the web UI, and he was like, ooh, that would be really good. So now maybe it's time to buy, which it's recorded someplace. He said it, not me, so I was very happy. Because I can feed my children. Please help me feed my children. Okay, so do the survey. I'm gonna switch to the demos. The other point I'll say is we got a very active Slack channel. So if you go to slack.solo.io, you know, try it. A lot of it's open source. All of our engineers hang out very actively on that Slack, maybe too actively because people are like, why do I need support? All these engineers are here. This is really cool. But give it a try. We love feedback. So anything you can do on this front would be great. Okay, so let me switch. Actually, kill this. Yeah, so we've done some work on that front so that you can actually, when you're calling out, so one, we can do, you can register external services like Lambda or static host port kind of thing. So we can connect to that. And when you're connecting to it, you'll actually get all the access logging and security capabilities. And we're doing work as part within Service Mesh Hub, the multi-mesh. We're actually dealing with multi-cluster, you know, ingress, egress. We're using Glue to kind of help with that. Both to kind of multiplex traffic as well as making sure that we've got the right security boundaries in there. So we're hoping to announce some of that at KubeCon in San Diego. So we're trying to do a lot of work on particularly multi-cluster mesh management. We really want to do a lot on that front. Hopefully I haven't given any secrets away, but go to KubeCon San Diego. Hopefully it'll be really cool in terms of the demos we're doing. It'll be cool anyways, but it will also be cool for us. Okay, so 2 demos I'm going to show you. So one, kind of in that modernizing vein, taking the classic Spring Boot, you know, Spring Pet Clinic application. Ooh, okay, whatever. You know, I put this, I just happened to containerize this, put it on this is running on GKE. This demo would be the same even if it was running standalone in an app server. I'm just using this as a prop. It's connected to a MySQL database. Is it running? Yes. Whew. This is always the nervous part when I switch. So it's connecting to a database. That's great. So, you know, if I had a page now, so if the business came and says, hey, I want to go and add a 3rd column to my environment, and I want to experiment. I want to start playing with microservices. Maybe, you know, somebody said Go looks really cool. I want to do this in Go. You know, I know how to do it in Java. I know what that time frame is. It's going to take some work. Okay, whatever. But I want to try this in Go. So what would that look like? You know, how do I take a Java application and kind of put a Go page someplace in here? So this is where Glue can help. And again, that idea of how can I do safe experimentation? So this is the Glue web administrative console. Right off the bat, you can see, you know, in this case, we've got switching back and forth. I can't talk and chew gum at the same time, so I'm trying desperately here. The Envoy, we actually, in this case, we've got one proxy that I've deployed. It can actually tell you if, you know, has the configuration successfully been pushed to all of the proxies that have been deployed out. Occasionally, you might have a network connectivity issue. One of the proxies out of sync. You want to know that. Envoy will, well, the way Glue works is that if a configuration is valid, we'll actually push that configuration Envoy. If the configuration is not valid, if you set up one of the traffic routing rules, you pointed it at something that doesn't actually exist, we'll flag it as an error, and we will not push the broken config to Envoy, because that would be bad. So Envoy will work on sort of the last known working version. And you can use these kind of consoles to detect that and know, hey, what's been deployed or what's not. We can show you the catalog of services as a convenience, kind of helps you figure that out. So we'll auto-discover all of the Kubernetes services in the cluster we're involved with, including, I happen to know this pet store service actually has a Swagger, an open API spec associated with it. We'll actually discover the functions that are dealt with that. We'll do the same thing with gRPC. So now you can actually route not just to host and port, but actually to individual functions. So we've got some people that are using this to do maybe like gRPC to functions or whatever, that they can basically, we have a request we're working on, actually the ability to auto-generate a Swagger API based on the virtual interface that you've exposed out. So kind of a way to kind of composite your own APIs. But that's there. But I also, like I said earlier, this is running on Google, but there's this Amazon thing. What's this Amazon thing? I set up credentials to point at an Amazon cluster. And it went out and auto-discovered, oh, okay, I got these 6 Lambda functions that are also running. Cool. I could do the same thing if I wanted to register, if I had console running, I could connect to that. It would list, here's all the services in console, here's all the static services you've registered, et cetera. So it can kind of find all of these things on the platform and off the platform that you can route to. Kind of cool. Okay, so what does that all mean? So we've got a concept of a virtual service, very analogous to kind of what Istio does, though simpler and better. It's using the same technology. I try not to beat up on Istio. Istio does a lot of really, really good things. Somehow it manages the traffic routing is a bit clunky, in my opinion. Their API isn't as clean as it could be. So we've tried to put a lot of effort on that. Same underlying routing technology. At the end of the day, we're both translating to Envoy. So it's the same kind of thing. So in this case, I've set up a virtual service and I've told it all traffic is going to go to the Pet Clinic app. Cool, right? So that's what we saw. But I want to change that. So I used my example of, I built for the vets page, I've got a Go app. So I've got this other Go service, Pet Clinic Vets. And what I want to say, typing with one hand, is any query, any route, right, so any URL that has a /vets prefix on it, I want to send that traffic to the Go app. But everything else I want to send to the Java app. And you could do header-based routing, I could do query paths, I could do source and destination IPs, I can do lots of other kinds of things to match routes. But we're going to be simple here. Whoop. Okay, cool. Yep, look, and the little button turned green, very happy about that. This is always the, they skim the wall, kind of coming around. And if we go back to our application, if I refresh, ooh, look at that. Third column just pops up. So you can see, maybe you can see at the top, it's /vets.html. Well, it's catching it, /vets. So it's saying, oh, okay, there's that prefix. That goes to now the Go application. But the rest of the traffic is still going to the Java application. So this is still just the Java stuff, and I can kind of do that thing. Cool. And if we wanted to keep going on, like, oh, nobody implemented contact page. So I can come back here, and I say, hey, I'm going to keep my experiment going. I'm going to go to Lambda. I'm going to try a Lambda function. Why not? And I know like contact form 3 is set up. If I type it right, I'm going to do contact. Now, who's played with Lambda here? Maybe play with Lambda? So does Lambda return HTML? Lambda functions? No? Oh, nobody's played that much with it. So Lambda, what comes back from Amazon Lambda is a JSON object. So your function might return HTML like mine does, but Lambda actually is going to return to me as an external user JSON. Well, that's not going to work. I don't want to see JSON on this. I want to see HTML. So Glue actually has the ability, Envoy has the ability, we've created a response transformation engine. So the JSON object that comes back from Lambda has a body key, and that's the value that comes back from your Lambda function. So we actually built a little response, because it's such a classic case, we built a common transform to say, take the value that's associated with the body key and replace the HTTP body with that. Kind of cool. So what does that mean? Just, if I did it right, if I go to contacts, I'm just going to see an HTML form. So now I've got Lambda, I've got Go, and I've got Java. So again, safety. And if I don't like one of them, I'm like, hey, the vet thing, actually I was kind of cool with 2 columns. I don't really need the 3. I can just delete that, go back. Oh, okay, we're back to the Java application. So again, the idea that you can safely experiment, I want to try, let me try an experiment with Go. Did that work or not? Let me try it with Lambda. Does that work or not? So I can slowly I can add business capability at the rate the business would like and evolve my application at the speed that's right for the application. as opposed to doing unnatural acts of like, let me jam my Java application. I got to turn it around in a week, even though we've only been doing like 1 month cycles. But now I got to turn it around in a week. Oh, that's bad. Lots of bad things there. So now I can kind of experiment and do a lot of very cool kind of traffic routing around this. And again, like Felix talked about it with DTech, they're using this to actually kind of composite together multiple microservices to make up an application. Because underneath the covers, with Glue, I'm talking too long here, but so if we look at what the config is, just a bunch of YAML, right? It's like, this is a manifest. It's like a deployment, it's like a service, it's like, you know, any other artifact you're deploying into Kubernetes. You can version control this with your application code. So like your deployment, all the other manifests, you can version code this as well. So I could say maybe, you know, version 2 of my app is going to have contact and slash, and then version 3 will have vets. And if it doesn't work, I can roll back. Hey, that's kind of cool. So I can do all my version control, I can do all my standard tools, and I can manage that through this. It's very, very powerful, I think. Okay, so that's all kind of cool. So the other thing I'll show you, I'll try and be quick about it, is service mesh. So this is we've got a read-only version of the app, and I'm going to show you a rewrite version in a second. If you go to servicemeshhub.io, you can kind of see this and play with it. This one we've deployed on Amazon. So it's auto-discovered the fact that AppMesh is there. You can't install AppMesh. Yeah, you know, it's part of Amazon. You turn it on. Amazon can install AppMesh. So we discovered it, that it's there. But in the same cluster, we also installed Istio and Linkerd. A little unusual, but not beyond the realm of possible, that I'm going to have multiple meshes in one cluster. You know, and it's going to tell you, here are all the services I found, and then you can build extensions on it. So let's have some fun. Again, because I'm crazy, so I built a cluster, Kubernetes cluster, which is still I'm connected to, that can't really see. So I just set up earlier today. I installed, I think it was Istio 124 into a vanilla Kubernetes cluster. Great. So let's go install Service Mesh Hub, see what happens. So up on our site, it gives you all these nice little instructions. So you can do the magic, you know, our very sophisticated installer of kube applying something. Now, of course, in practice, you would never just go randomly take some YAML that's on the internet and just apply it to your Kubernetes cluster and start, you know, allowing us to Bitcoin mine on your Kubernetes cluster. Thank you very much. Also helps me feed my children. But so definitely go look at the YAML file, go figure out what we're going to install. Trust me, it's fine. It's just Service Mesh Hub. It's going to be fine. But that's going to be it. So we're going to install that into our cluster. Then we're going to go back here and look at what step 2 is. And we're just going to port forward just to make it simple so I can get, because this is on a remote cluster and I don't know what the DNS setup is. So I'm going to get a local port mapped to my cluster. And I talked long enough that things started enough so that I can actually do this. Cool. And then I'll go to, all still with one hand. Getting a lot of practice at this. Woohoo! So we just installed Service Mesh Hub. Wow, that was hard. Ooh, I'm sweating here. It's really easy to install. And it went off and discovered that Istio was installed in the cluster. So right out of the gate, it discovered that, you know, that, hey, Istio is already there. And if we said, you know, that's cool, but, you know, I kind of dig Linkerd too. You know, I'll call that link. I'll call it, you know, link.system misspelled. Should leave the misspelling because then you'll know that it's true. So I can go install Linkerd, and it's going to start spending some cycles doing that. So very easy to kind of spin up clusters, to experiment with different service mesh technologies. What we've also put in here is this idea of extensions. So it's all cool that, you know, I got a mesh deployed, like great. now what? What do I do with it? It kind of does some of its thing. But then there's a set of applications, Kiali, we talked about earlier. Kiali can actually go and interrogate and kind of visualize what your mesh is. Maybe I want to deploy that onto my mesh. Now, for it to do that, it needs to know, well, where is the mesh? Like, what namespace did I put it in? What's the technology? Maybe I need, like in the case of Flagger, it does canary rollouts. It needs to know where the mesh is to do traffic shifting. And it needs to know the instance of Prometheus that's configured against that mesh to actually figure out, is the service being healthy before I roll more and more traffic out to it, right? It's kind of automated this canary deployment. So it needs to know where those are. So I can kind of, I can go and install this. So there's descriptions. I can tell it, what version, different flavors, where do I want to put it? We'll put this in Istio system, and it's basically a templating mechanism. So we've worked with some third parties around this, but there's nothing to stop you all from building this as well. So if you've got some pieces of technology that kind of need to know some of the details of it, it's kind of a little bit like a service mesh package manager, if you will. I can deploy componentry onto it. It knows what the underlying things are. And if I change it, if I reconfigure Prometheus to someplace else, it will go update the components for you. So you can kind of use it to kind of operate on some of that front. And then there's some demos in there as well. Again, the sort of this version, we kind of set it up to make it easy to play with it. So this is the canonical book info from Istio if you played with Istio. And again, we're pulling over a lot of the, again, it's a preview, sneak peek, because we're all friends here. At KubeCon San Diego, we're going to do some more announcements. We're going to refresh a lot of this console and put a lot more operational control into that as well. So, and we're hoping to, fingers crossed, we're going to get multi-cluster deployment fully visualized up here in the console. So if you've got Istio deployed in multiple clusters, it'll show up, and those units will be here in the console itself, so you can kind of do some interesting things there. And I'll stop there. I'll put up the book thing. But any questions? Yes? The Lambda? You're asking that the Lambda and the UI? Yeah, no, so I see. So the question is on the Lambda function, we convert it to the UI. So the Lambda function, that contact form 3, the Lambda function itself actually returns HTML. But the way the Lambda, so the function that's written, I think it's in Go in this case. So it's a Go function that actually returns an HTML package. But Lambda, if you call it from an outside source, it returns a JSON object. So it takes the results from the function and it puts it into a JSON object. And what we did was I clicked the button on the transform. So Glue is going to take that JSON object coming from Amazon and it extracts the results of my function, which happens to be HTML, and says, okay, I'm going to take this, I'm going to replace the HTTP body with that value, and then send it on. So it happens to work in my case because I knew I built the Lambda function to return HTML, and once I kind of dealt with how Amazon kind of monkeyed with it, then I got it to display. But that's because I built it with HTML. Does that make any sense? Did that answer your question? So we're not magically making it HTML. No, but all we're doing is, so if anybody who calls from outside Amazon, if you call an Amazon Lambda function, the result you're going to get back is a application JSON piece of content. And that's not going to display very pretty in a web browser. So that little, when I click that button in the Glue console, I can find it. When I click the little transform response, this is in Envoy when we send the request off to Amazon for /contact. When we get the result back, we see that it's a piece of JSON. We search for one of the keys that's of type body. We grab that value and then we replace the HTTP body with that value, which I happen to know is HTML. Yes. Yep. So so we are doing transformation. Getting JSON back from upstreams, very common scenario. Certainly very common with Lambda, but very common in a lot of other patterns too. A lot of REST services tend to use like JSON or XML. So the fact that I can extract pieces of that, we can also do like things like request. There isn't a click button for this, but you can also do request transformations. It's also very common to like add headers to a request before sending it up to another system. So that tends to be a very common pattern as well. So you can do some light, I qualify this as light transformation. I did a lot of work in the Apache Camel community for a long time. This is not an integration technology. You don't want to do heavy transformations in here because it's in your request path. It's going to add a lot of time. You don't want to do that. But there are cases where you want to tweak the headers a little bit or maybe tweak the response coming back. And so this allows you to kind of do that. Yep. So the question's around TLS. So Glue itself can terminate TLS if you want. So you can register a certificate with it and it can terminate the TLS connection. We can also pass it through. Glue can actually handle, we do TCP routing as well. So you can just take the traffic and just flow it through. And then Glue can establish a TLS, can use HTTPS to connect to upstream services as well. And we can also, we've got integration, I didn't touch on, but we have integration with like Istio and App Mesh so that you can actually do mutual TLS. So it'll coordinate with the service mesh to actually do a mutual TLS coordination without having to, proxy our proxy. We'll actually connect with the security context with that, if that makes any sense. So we can receive TLS connections and we can make TLS connections out. So we can do both. Yeah. Yeah. No. So Glue itself, I run it on my laptop. In this case, I run it on Google, but it runs on the laptop fine. It's probably, like 1 to 2 CPU, like 1 to 2 cores would be more than enough to kind of do what it does. I forget exactly if I did all the math around how we set up the resource limits, but it's probably on that order of like, 1 to 2 cores total, tens of megs of memory. All of it's written in Go. So it's pretty small and fast. So it's Glue itself adds very little overhead to the overall system. Yeah, so you can run it on Minikube on the laptop if you want to play with it. You can use Kind, which is very cool. Kubernetes and Docker is actually super cool. I've been doing a lot more of that. If you get Docker desktop on their Mac, it's very lightweight and quick. The only thing you got to realize is you got to set the kube config, which I always forget, but if you set that, then it's super cool. So I can run a couple of clusters on my laptop. It's not that great a laptop, but I mean, you can do that and it works fine. So it's very, very lightweight and you can do lots of things. As soon as you add Istio in or things like that, then it gets a little bit heavier because then Istio will probably take, a couple more cores that you're going to want. So, by the time if you have Kubernetes and Istio and some other things going, then that might start to stress your machine out a little bit, but it's not that big a deal. I think even when I run it on Google, it's probably, like a 3-node, it's like 6 cores total, across 3 nodes. This is what the typical setup I'll do for Istio, and it works pretty well. 6 cores on a 8-core Mac, it doesn't leave your machine much else room, so it kind of, sometimes it freaks out a little bit if you get an IDE and some other things going. It's pretty lightweight. Yep. Yep. Yes. Yeah, so the question's about Service Mesh Hub. So it's available. I mean, you saw it if you go to, you go to servicemeshhub.io. I mean, this is our public site. I just ran the demo as though I was one of you all. So you all could do exactly what I did. And it hopefully should do exactly what you saw when you try it, if we did the right thing. So it's all out there and free. to try now, and we love feedback. So if you're giving it a try, if you get thoughts around it, join the Slack, give us feedback. We'd love to talk to you more about it. And we're doing a lot of work on this. Again, there's a hope that we're going to do some big announcements around it at KubeCon in San Diego. So check out that too. KubeCon San Diego, very cool. Always a good time at KubeCon, especially if you love like service mesh stuff. Any other questions? Cool. Thank you very much. Remember the survey. Get a book. Cool. Thank you. Hi, Scott. So